Okay, let's rock the ratios. So ratios are similar and different than fractions. We're going to have to figure that out. And I'm about ready to sneeze. And okay, it passed. But we're going to label every ratio in order to I just keep thinking about sneezing, I swear. Okay. We're going to label ratios, and that is going to be a huge difference between the ratio and the fraction. We're going to apply equal ratios and express the same rate but in different forms. So let's start off with just the ratio itself. Relationship between two or more numbers that indicates for each of the first how much of the second. So it's all about amounts. Here we go. To me, this is a relationship. Between two or more amounts of different quantities it's going to indicate the amount of each within it. So let's take a peek. And I also wanted to mention that I want to mention this. Label it. Label everything. That's going to be the key here. So let's talk about these daily situations. Write a ratio for each of the following scenarios. Okay. 60 miles per hour. Okay, so 60 miles. Usually when we say per, we write it like that as a fraction, actually. So we could write this as 60 miles per 1 hour, where we write it actually as a fraction. We could write it as a slash, which indicates a fraction, or we could write it with colon. But if you're going to do this, make sure, like I said up here, label, label, label. 60 miles per every 1 hour. That's our rate. Shirts are on sale at a cost of $10 for every 3 you buy. Got it. Cost is $10. And notice my unit label here is actually a $sign because that's quicker and all about that. For every 3 shirts. Or we could write this as $10 in the numerator over 3 shirts. Believe it or not, we could also look at this a little bit differently and say that's 3 shirts for $10. All of this represents the same cost rate. So same ratio. $10 for 3 shirts, 3 shirts for $10. It's one of the really big differences between a fraction and a ratio is that if in a ratio, if you take the reciprocal of it, it has the same meaning, but you just moved the labels. And the labels were different for the numerator and the denominator. Whereas in a fraction, this would be 3 shirts out of 10 shirts or what have you. They would have the same units, and you would have to be very careful about what the numerator or the number of equal portions is versus the denominator, which is how many total are in a complete whole. So, a little bit different. You get $10 Kohl's Cash for every $50 you spend. I have no idea if that's true. All I know is that they always try to get me to use Kohl's Cash. So, we got to make sure we write this very differently. Let's go. No, I can't use a $sign because it just makes it so confusing. How about 10? 10K. I'm going to write it all out. 10 Kohl's Cash for every $50 you spend. And now I can use a real dollar sign there because that's actually like real money. So, you're going to have 2 parts sugar to 1 part water. So, 2 parts sugar to 1 part water. Or 2, label, 2 sugars for 1 equal part water. Something of the sort. 1 water for 2 sugars, whatever. 9 out of 10 dentists recommend Trident to other types of gum. They did not pay me to put it in here. It's just on those commercials. And nonetheless, so this is 9 dentists out of 10 dentists. So 9 recommend out of 9 out of 10. 9 recommend to 10 total. Okay, we could write it like that. 10 total dentists. We could write, let's see. We could write 9 recommend for every 1 that do not. That's another rate here. So, because then you have a total of 10 dentists. Okay, she runs 2 miles in 18 minutes. Okay, as a ratio, that would be 2 miles in 18 minutes. Or if you wanted to simplify that, 1 mile in 9 minutes. But I gotta say, maybe not. Usually if you're running 2 miles in 18 minutes, your first mile is a little bit faster than your second mile. And so this might not actually be an equal rate. So running, equal rate, I'm not sure about that. Like, I run a mile in 10 minutes, and I could assure you that my second mile, definitely longer than that. So nonetheless, 2 miles in 18 minutes, or it takes 18 minutes for this person to run 2 miles. Whatever. Okay. You need 2 adults for every 15 children attending the field trip. Got it. 2 A's for every 15 C's. Or you could write 15 C's for every 2 A's, or you could write 2 A's for every 15 C's, but you're going to have to label it. Catch my drift? Illinois daycare law requires 1 adult for every 5 toddlers. They're very challenging. They're demanding. So 1 adult for every 5 toddlers. Unit ratio. Okay, where one of the numbers in the ratio is a 1. So this is actually a unit ratio, but this 2 adults for every 15, not a unit ratio. This 18 minutes for 2 miles is not a unit ratio, but this 1 mile in 9 minutes, that is a unit ratio. This 9 recommend out of 10 total dentists is not a unit ratio. You could say 9 recommend compared to for every 1 that does not. That is a unit ratio. 1 part water to 2 parts sugar, that is a unit ratio. This is not, but probably could be rewritten as 1. $10 Kohl's Cash for every $50 you spend. That would mean 1 Kohl's Cash dollar for every $5 you spend. I don't know, maybe that's true, maybe it's not. But that certainly is the same rate, but as a unit ratio. The 3 shirts for $10, not a unit ratio, but the 60 miles in 1 hour, that is a unit ratio. So, unit ratio. one of its quantities as a singular amount. In other words, it has a 1 in it. Okay? That's a unit ratio. So, some remarks. Let's see. I like to consider ratios sometimes they're a fraction. You can write them as a fraction, but they relate quantities from different wholes. So, ratios can be written as fractions. But the quantities come from different wholes. And that's what's very different about ratios, okay? Is that in a fraction, you had a whole and you had equal portions. Hold on a minute, please. That's my kiddos. And you had an equal amount of portions within that. And so your label on the numerator would be the same as your label on the denominator. So, 1 inch out of 2 inches. Well, 1 inch out of 2 inches is half of the 2 inches. So your units would be exactly from the same whole. Or 8 stars out of the 24 stars is equivalent to 1 star out of every 3 stars. So, fractions can be rewritten and labeled as ratios, but ratios sometimes come from completely different wholes. For instance, miles and hours. They're very unlike quantities, but we write them as together as a rate. Ratios are built to describe constant rates of change. So ratios describe, that's supposed to be a C, constant rates of change. Got it. And that's why I kept like hemming and hawing about the miles in 9 minutes. 1 mile in 9 minutes is equivalent to 2 miles in 18 minutes. Maybe, maybe not. Like, I don't know if a runner would really do that. Also, there are definitely instances, like what I was just talking about with the runner, where ratios should not be used because you cannot depend on the fact that it'll be a constant rate of change. So sometimes ratios should not be used. And in particular, this is when the rate could be inconsistent. Okay? Let's look at example 2. Homes and incomes. This table gives the average sale prices of existing homes and the average incomes according to regional data from not this census, but the old census. Census is very important. Be counted. Okay? Also, I'm sure that the pandemic is going to have a huge impact on both of these numbers. It would be interesting to see how this compares to what it will be soon. Okay, here we go. It says, find the unit ratio of median sale price of homes to the median income for each region. Okay, immediately I got out of my handy calculator because I look at those numbers and I'm like, yep, I don't really see 1 to 2 there, or 2 miles in 18 minutes type of scenario here. Okay, let's look first at the Northeast region. Okay, median sales price of the home to the median income. Okay, let's do it. But we need to turn it into a unit ratio. So first, I'm going to write the ratio. $288,100 for the home to a median income of $52,274 salary year. Now, we're going to turn this into a unit ratio. I'm going to scale this down by 52,274, and I'm going to have to scale this down by the same amount. So, let's do that quick. I have another color. I like using colors. Scale down by 52,274. Scale it down by 52,274. For every dollar income that you have, how much are you spending on your home? So 288,100 divided by 52,274. Okay, on my calculator that is very bright for this screen, I got you spend about $5.51 on a home for every $1 of income you make in the Northeast. Okay, let's do the next region. Here we go. Midwest. Gonna do the same thing. So just so that everyone is very clear, this is my unit ratio because I turned this into a 1, unitizing it. In the Midwest, spend $161,400 on your home for $50,227 of income. And if I unitize this, I'm going to scale down by $50,227. Okay. So here, $161,400 divided by $50,227 annual salary. That means that for you spend about $3.21 on a home for every $1 of income in your salary. Okay. Here we go, and I think I'm going to run out of space here. So what I'm going to do is I'm just going to do them quickly and write them up here for their unit ratio. This was $5.51 on your house for every $1 of income. Midwest was $3.21 on your home for every $1 of income. And let's go in the South. I can hear my kiddos singing and my husband cooking. Okay, in the South, spend about $3.85 on your home for every $1 you make as an income. And then in the West, so how is this looking over in the West? $342,500 on your home for $54,138 of income. Ooh, that's expensive. $6.33 you spend on your home for every $1 of income. I don't know, what do you got? Like the Valley, and you've got, it's pretty expensive to live in California. Now, I want you to, okay, what does each ratio mean or represent in the context of this situation? So I've been actually saying this repeatedly, so we're going to actually write it. I'm going to go Midwest style. That was, so for, this is the Midwest. For each $1 in income, a Midwestern makes per year, they spend $3.21 on their home on average. So, because remember, this median, that means middle. So, on average, for every $1 in income you make in a year, you spend $3.21 on their home. Okay? Now, remember, like, you don't spend 161,000 every year. Okay? So, this is yearly, and this is not. But nonetheless, I do want you to take a look at this number. Because when I look at this number, I think, there are some really expensive small homes or studios even in the city that are, I mean, they're way more than this. Like, that price in the city, that's really low for the city. But then I think about, like, near the Quad Cities and in southern Illinois, and homes there, like, for this amount, you would get a castle, pretty much. So I want you to just think about this, like, and that, I was just thinking about the state of Illinois, you know, that the median sale price of homes and the median income, even locally, is really different within the state of Illinois, not to mention, you know, the entire Midwest, not to mention the entire United States. Okay, so this is an average, and it's a big average of a lot of different places. So keeping that in mind. Which region has the most affordable homes, and which one has the least affordable? Okie dokie. Looks like we live in the most affordable home land. Midwest. Least affordable? Cali. One moment, please. Sorry, not you. My kiddos. Okay. Let's do some unit conversions. And then my husband just yelled at her, leave her alone, let her work. Okay. When I think about a unit conversion, I think about expressing a given quantity that is the same and equal measurement, but just in different terms. So, a unit conversion is a given amount or quantity is expressed using different units. But hasn't changed. Okay, so it hasn't changed in its actual amount. It's just been measured differently. So for instance, you know, if you're going to measure this length of this piece of paper, what is it, like 11.5 or something inches? Well, if you were going to use a different unit, say centimeters, there would be more of them. Except it's the same amount, it's just measured differently. So this length of piece of paper, it's the same regardless of how, so is this, here, let's try to zoom out here. Whee. So this is the same regardless of whether you measure it in inches or measure it in centimeters. It's just that if you measure it in inches, it's going to be like 8. And if you measure it in centimeters, it's going to be like, I don't know, 20 something. So, because centimeters are a little bit smaller. So, it's the same amount. It's just been measured differently. So, it's been converted with a different measurement. All right, let's convert some stuff. 4 minutes into seconds. Okie dokie. And it says, show the conversion factor in your work. Fine, I will. We started with 4 minutes. And that is my whole. And I'm going to convert that into seconds. I know that my ratio is that for every 1 minute, there are 60 seconds. Okay. So how many seconds is that? 240 seconds. Got it. 3 feet into inches. Okay, there we go. Now I can see a little bit better. 3 feet. I'm starting with 3 feet. That is my whole. And my conversion factor. Well, I know that there, in every 1 foot, there are 12 inches. Here's my conversion factor. And feet beyond. That makes it 36 inches. 3 times 12, 36. 1 times 1, 1. Got it. 360 seconds into hours. Ooh. So, 360 seconds is my whole, 1 whole. And there are 60 seconds for each 1 minute. Okay, so that means, okay, 360 times 1 is 360 minutes. And 60, whatever, divided by 60. I think that's 6. So now we have 6 minutes is our whole. And I'm going to do a conversion factor and multiply that by, okay, how many minutes are in an hour? There are 60 minutes in 1 hour. All right, very good. And I can scale this down by 6. I can scale this down by 6. I get 1. Okay. That's supposed to be an hour. 1/6 of an hour. So 360 seconds is 1/6 of an hour. Got it. It's easier to think of it as 6 minutes, but whatever. Convert 48 hours into days. Well, I already know it's 4. Wait, hold on. I'm sorry. 2, because there are 24 hours in a day. Nonetheless, I'm going to write it out. 48 hours is our whole. And I just said I knew that there were 24 hours in 1 day. Got it. Hours go away. 48 times 1 is 48. I'm left with the units days. 1 by 24 is 24. This is actually a division problem. I am writing out all of these labels because I need you to get used to it. Because in this course and in Gen Math or Gen Ed Stats or every time there's an application of mathematics, tagging it is the way to go. And this isn't just, and I just said gen ed math and I just said gen ed stats, but the reality is, so like people who go down that path, maybe they get psych degrees or whatever, labeling it is the way to go. But so do physicists and chemists and biologists. They always tag every one of their unit conversions with their labels and do this process, okay? So I'm just starting it now because we're going to use it for the entire duration of this class. $4.60 for 4 cans of soup. Write it as a unit ratio. $4.60 for 4 cans. Scale it down. I'm going to scale it down by 2 just because I can do that in my head. Half of 4 is $2. Half of 60 cents is 30 cents. And half of 4 cans is 2 cans. I can divide that by 2 actually. That is, so half of 2. Half of 2 is $1. Half of 30 cents is 15 cents. And half of 2 cans is 1 can. Got it. $1.15 per can. Convert $4.60 into pesos. Okay. And this was the worth of each exchange for pesos as of 2019, I think, or January 2020. Anyway, so we're starting with $4.60 US dollars. That's my whole. My conversion is for every 0.053. So for every 5 cents of US dollars, we have 1 peso. Okay. Convert my unit into pesos. Okay. Here we go. I'm going to take my $4.60 and divide it by 0.053, and I get, this is approximately 86.8 pesos. Okay, now, I don't know, like, you could round that to about 86 or 87. They're certainly not ever in a bank going to give you more than what it was actually worth. And this I rounded this up. It was 86.79. They're probably going to give you 86 cents, right? Nonetheless, there you have it. A few remarks to summarize this whole darn thing about ratios. Sometimes we write it as a fraction, and sometimes we write it with a colon. But notice that if we write a ratio like a fraction, if we write a ratio in the form of a labeled, I don't know if that's supposed to be 1L, whatever, fraction. Okay, and now keep in mind, like, we can write it like this, or like that, or like that. We just have to label everything, right? So here's the ratios, different ratios for the same rate. Then they behave like equivalent fractions. They behave like equivalent fractions. And here's what I mean. They scale up, scale down similarly. So if A is to B, then triple that, scale them up, then 3 of A's would go for 3 of B's. And if we have it written as A over B, or A to B in fraction form, this would be, right, triple it, triple each quantity, and that is equivalent to the original rate, or B to A. So if we have B to A, that would be equivalent to scaling them up by 3 3b to 3a's. So, ratios behave very similarly to equivalent fractions. And this is super important. All ratios need labels or people get confused. It's super important. I mean, and when I mean it's so important, I started with that and now I'm ending with that. Okay? That's the huge difference between ratios and fractions, is that they may or may not come from the same whole, and that's important. So, in summary, a couple of things. Ratios are rates of change, and it's only when the rate is consistent that we use a ratio. Also, a unit ratio has one of its quantities as a 1. Okay, so a unit ratio has a 1 in the ratio, and ratios are meant to describe constant rates of change. And we actually use a lot of these unit ratios in order to convert. So if we're in one type of measurement, we can use these rates of exchange, or these, seriously, down here, that's an exchange rate, in order to come up with our new amount. Okay, so ratios are used a lot. They're prevalent everywhere, and we're going to use them all the time. All right, I love ratios.